Hello, hello. Is it working? Can you hear me in the back? Yes, it is working. Great. So, hello, beautiful people. Welcome. My name is Tomáš Řehoř, and I'm from Pipedrive. I will be your host today. Let me start by thanking HUBHUB, who is partnering with us for the event tonight, and they are helping us to run this beautiful space. And of course, we are also partnering with Kiwi, Kiwi.com. Guys are not only here to speak, but they are also helping us to organize this event. So I thank them all. When I was thinking about the topic today, I realized that throughout my career there were always countless of technologies available, countless of technologies to try, and there was never enough time to try them all. So I wanted to bring you 3 different point of views from 3 different companies and their experience with specific cloud technologies, and maybe it will help you understand better what are maybe some wins, some losses. I'm sure they will tell you about both. So that was the motivation behind Cloud Stories. Today you will hear from Matěj from Storyous. Also hear from Kristo Kaiv from Pipedrive about our journey to microservices. And after a break, you will hear from Tomáš Papež and Kiri, I should have practiced this. Kiri Chinsky from Kiwi about their journey to Google Cloud. So I hope you will enjoy it, and you will also stay with us afterwards for more drinks, more importantly, more food, and also networking. If you have been to some of our previous events, the format this time will be a little bit different. We will do Q&A after each presentation. If you have questions during the presentation, you can ask them on Slido. You can go to slido.com, and if you enter event number 7849, which is also written here on the whiteboard, in case you forget it, you can ask questions then, or after that we will be doing mixed questions, some from Slido, and we will also hand out microphones, so you can also ask questions live. So that's about the format of the event, and without delaying it any further, let me welcome Matěj Koubík from Storyous to start.
Hi, my name is Matěj Koubík, and I'm not gonna present any public cloud technology you can use, but I'm gonna rather present some custom solution we have made up for our needs, and you can inspire with that. So that's a little different. So yeah, I'm from a company called Storyous. Who does know Storyous? Yeah, there are quite a lot of people. That's great. So what we do is basically we help restaurants or restaurant owners to manage their place, to improve their business with data, technology, and so on. So our main product is this point of sale application that is used by the waiters at the place. And we also have some backend applications for the business people to manage their place. So, yeah, these are two our products I'm gonna be talking about. One of them is our web administration. This is used by the place manager or something like that. He makes some setups the menu for the restaurant, makes some changes, sees the reports. He can see how the business is going, and basically what I'm gonna focus on today is delivering changes between applications. It's gonna be like when you change something on the backend, how it's gonna propagate to the client application. The client application is the POS, point of sale application. It's basically smart cash desk. and it's used by the waiters. It's just an Android application on a tablet. And usually in a restaurant you have multiple tablets, and the waiters use them. And they don't have to be always online. You go to the Wi-Fi, then you go offline, then you are on another network, and everything has to be smooth and updated all the time. And that's the problem we are facing all the time. And yeah. When we talk about delivering messages or changes between applications, there are two kinds in our case, two scenarios or two use cases. One is when you change something on the backend and want to propagate it to all the applications, like something has changed on the menu and you have to see the change on the tablet, or some update of the application itself is available for you, or something like that. And the other kind of updates is between the clients themselves, like as a client of the restaurant, when you order some meal and a beer on one tablet, and then you go to pay to the bar, and you have to see the same state of the bill on the other tablet. So that's what we are facing. And I'm gonna shortly describe legacy solution we have had historically. It was based on the TCP socket. It sounds cool, but it's not that much cool. It's unstable because it's just a socket. If you send some data to it and the device disconnects, it's lost. It's not scalable. Historically, we have had just one monolithic backend application on one instance, and all the clients were connected directly to this one instance. So we couldn't easily scale the backend. It's not cloud friendly. If you have an application that has some HTTP endpoint on a port 80, you can use whatever tooling you need. You have all the caches and gateways and load balancers. But if you have a custom proprietary protocol on a custom port, that's not that happy. You are not that happy. And also debugging was not easy because we were not persisting the messages, we were not logging them. If somebody complained they didn't get the update or something was in different states on different tablets, we had no way to debug it, basically. So we are thinking about, but it was fast. That's one thing that's good about TCP socket. We are thinking about what we really need for pushing our changes to the clients, and we have came up with this idea that speed is not usually that important for us. When you order a beer on one application and want to pay it on other, if it's delayed for 1 minute, it's okay. If we release some new version of an application and want to test it on 10% of our customers, if they update in an hour or tomorrow, it's usually okay. So these kinds of updates or messages or push messages aren't that the speed is not critical for them. What is critical is reliability. We want to be sure when we push some message to some set of devices, we want to be sure that it's going to be delivered. We wanna see whether it was delivered or not, what kind of messages are being delivered, how much of them, and so on. So we want to, like usual things, monitoring, debugging, some alerting if things don't work as expected. We want scalability, to be able to move to cloud and to divide our monolithic backend to microservices, and reliability, and we want that simple design, because in our experience, when some part of the system is complicated in its design, there's going to be trouble with that part. So we have came up with something we call Message API. It's very simple in its core idea, but it's pretty flexible for many use cases. The message Every update possible in our system is represented with a message that is very simple. It has some recipient. Every client that wants to be pushed with the messages have some device ID. We have the type of the message, like menu of the restaurant has updated. That's like what type of event it is. And it has some ID. The ID is just a string. That's that the sender, both the sender and the recipient understand what the ID means, but it's just a string. And the type of the message is just a contract between the sender and the recipient. Like if you get message of this type, do this and confirm you have done that. Like update your menu. So it's very simple. There's no other payload that would be pushed through the message. All the other data the client needs it has to get it from the API. And the workflow is pretty simple. Like the client, the sender pushes the message to the message API, and the client gets the messages that are for him and does some action according to the type of the message. Yeah, and the great thing is it has 3 different layers it can operate in. It has some happy scenario, but when something goes wrong and the API is down or doesn't work, it has plan B and it also has plan C. And I'm gonna start from the plan C because it's the most simple case. It's when everything is offline, nothing is working, just the sender and the receiver are online. No messaging infrastructure is available. So in this it has a backup mechanism when the recipient asks the microservice each 10 minutes, depending on the type of the API, if there is some change. For example, you have an API that manages the bills, and the client, the POS application, detects that the message API is offline, so it asks each 10 minutes, it asks the bills API if there is something new for him. If the message API works, it goes faster. You don't have to wait 10 minutes before you get the message. The sender, there happens some change on the backend. It pushes the message to the message API, and in some shorter cycle, the recipient asks message API if it has something new, some new message. It doesn't have to ask or get or hit 10 different APIs to get all the changes different. It just get aggregated list of messages from the message API. So basically, I ask the message API, is there anything new for me? Yeah, there are 3 bills that have updated. The daily menu is not available anymore, and there's an update of the application and 2 new orders from some delivery service or something like that. And the client then knows what APIs to ask. And to make things even further, there's a happy case scenario where everything is working. The message API is working, and we even have some push message service. We use Pushy for this, and that's a mechanism when message API receives some new message for the device. It pushes not the message itself, but just pings like you have some new messages. So it's instant. When you do some change on the backend, it's instantly delivered via the push message. If that doesn't work, if the push service is offline, or not working, it doesn't matter. It just asks regularly the message API. If the message API isn't working neither, doesn't matter. Every 10 minutes, as a backup, it asks all the APIs if there's anything new. So that's the main point of the design. That when things go okay, when things work, it's blazing fast. But if something goes bad, some part of the system or the infrastructure doesn't work, it still works. It's just slower. So we haven't used any third-party application or service for messaging. We have developed our own, I think, pretty simple solution that fits our needs, and it allows us to debug the messages, to see what's happening, and it increased the reliability of our whole infrastructure pretty much. So it may be an inspiration for you if you're not satisfied with some messaging or some part of the cloud applications you are using. You can implement it your own way, pretty simply. Okay, and that's pretty much all from me. And yeah, if you have some questions or Tomáš will maybe host.
There are no questions on Slido, as I can see, so let's ask in the crowd.
Yeah, I was just curious, what do you think that was the advantage of rolling your own solution over using the different things available?
Yeah, the main reason we did it is it's not that much like a substitute of some third-party solution, but it's rather an addition to it, because we've been using some push messaging services already, and we just wanted some place to store them, to persist them, and to make it reliable. So we use here we use Pushy for actually pushing messages or pushing just ping the device, but we also have we can easily switch this part. We can if the service becomes unavailable, we can use something else or so on. But we still have our own place where we store the messages, and it was not that hard to implement. It was pretty.
Most third-party messaging didn't have persistence then.
Yeah, they had, but. Yeah, we had the other thing. The other advantage is that we wanted to like have control about different types of the messages, like to have different timeouts for them and so on. And now we can like it's not just a message. Like you get the message, but you also, as a client, you get the message, you do something depending on the contract, and then you confirm you have done that. It's, yeah, like, or is it okay like this?
I haven't had anything about collisions.
Yeah. What kind of collisions? Like
Any collision. You don't have collisions?
in the shared state, or yeah,
You go offline.
Yeah, that's
two devices.
yeah.
And they
Sure we have, but that's a different story. That's not part of this. What the message API solves is just it notifies you that the state has changed. So of course we have like collision, the kind of collisions like when you on some offline device you order a beer, on different offline device you order another beer, and like you pay the bill on the first one and you don't have there's no way to see the other beer if you are both offline. But we are implementing something we call full offline, and that's a new thing that's going to be available soon for our customers. That when you are offline, not on the internet, but all the devices are on the same network, then the state is shared by themselves. So it's, but it's not part of this. This is not intended to solve these kind of problems. It's just pushing the messages, not solving the collisions. It's like.
Oh, hi. Who is responsible to confirm the message was handled?
Yeah, that's the client. In this, yeah, I'm gonna. In this case, this is the client. He asks the message API, get me all the new messages for me, and in the same call, he also confirms, sends the IDs of messages that he has confirmed, that he has received. And the confirmation means not just he has received, but he has done some action according to the type of the message. So if you have a type of the message like update to this version, it's confirmed when the client actually updates. Or when you have a message like there's this bill updated, the message is completed when you actually download the new data and update your internal state. So it depends on the type of the message. There's always, it's a contract between the sender and the client, and they both have to know what it means for the message to be completed.
Okay, I see there the possibility that you can receive more the same message, for example, update or new reservation or something like that twice. So by design, because you can lose some communication between the service, between the API and so on. So by design, your handling is idempotent for all messages, or how can you handle to receive the message twice?
Yeah, if you want to confirm, yeah, all the actions that are defined by the message have to be idempotent, because it's possible to receive the message. As a client, you want to confirm it, but you fail to confirm it. Yeah, then you get the same message again, but you already know you have received this message. So all the clients keep the messages with them, and when they receive the message, they see, yeah, this message I have already seen.
So, hey, my question is about timeline. So, how hard was it to develop? When did you push it? When it was online? And what are the outcomes? Like, do clients, like your clients, know? Are they aware of the change?
Yeah, yeah. We have the main reason we have been developing it were like unsynchronized bills, like. Our clients were calling with problems like we pay some bill on this device and it just appears again, or some bugs like this. So we were investigating about it. We realized that the TCP socket was actually the problem, and we spent like some weeks by just talking about it, finding the right design, and then the implementation of the API was quite simple. It was in a week, maybe done. But then we've been moving the business logic parts of the application to this new system. So it was gradually, but the main reason was to be able to update the bills in a more reliable way. And the other thing was that when you are printing some bill on a printer, you also have to, if you don't have the printer connected directly to the device, you have to also send it some way. And it was also like our customers also complained about these prints being slow or not being printed at all. And so these are two things that improve dramatically, and yeah, I think our customers are aware of it.
I have maybe one last question for you. Out of all the speakers today, your product is probably the closest to the physical world. You cannot order a beer, you cannot order your food if your services are not working. How close did you get to angry customers when you were solving some problems?
Yeah, as a developer, we don't get in touch that much with customers, but sometimes we are in our offices. We are just next to the customer care, so we like when something goes wrong, we know it. And yeah, sometimes yeah, we usually sometimes we go with our laptop to the restaurant to debug something in their network when something's slow or something. So yeah, we get in touch. But frankly, we are pretty shielded from the customer world as development team.
Okay. So, you want to ask something? Okay.
I was curious what you had to do in your architecture to future-proof your whole setup, so you could add, say, different customers, different kinds of systems, scanners or other devices.
Like in relation to the messaging or
No,
or
well,
generally?
not just in general, how you, like, what effect it had on your design, how careful you were, or did you find where you...
To support more customers or
To support the next shiny thing.
yeah. Yeah, I think if I had to put say one thing, that would be that we are pretty prepared for changes. Like when we design something, we are prepared to delete the code or to change it. So we try to design things as small components that are pretty simple, and they have multiple purposes, and they can also be changed dramatically if needed. So that's I think one thing that's pretty important in our design process. And we also make things simple, like oversimple sometimes.
Okay, let's continue with more questions over a beer later. Thank you, Matěj. Now let's welcome Kristo, who came from Lisbon.
Yes, thank you. On? Nice. So, hello. My name is Kristo. I don't look very Portuguese, I guess. It's because I'm not. I'm originally from Estonia. But I moved to Lisbon a while ago. And yeah, as for the questions, I don't know if we have time for that many. So use the Slido. Actually, do you use it? I have to go in the light. I think, yeah, follow the light. So, yeah, let's get started. Clicky, clicky, clicky. Okay. So, about me. I was 8 years at Skype. I even managed to almost live 1 year on and off here in Prague, like constantly going back and forth between Estonia and Prague. Was mostly working with databases, also as an engineering manager on one part of the product in Skype. Then 1 year in GrabCAD as a developer. You probably don't know what GrabCAD is, but it's a company that was kind of oriented on cloud-based CAD files, analysis, design, different kind of aspects. They got bought by a printer company, this 3D printer company later on. And now I've been 4.5 years in Pipedrive. Originally joined as developer, then I became team lead, then actually for the biggest part of the time I've been architect, head of architecture. And yeah, today we'll talk about Anarchy. So my main focus in Pipedrive has been, during the time when I was the architect, as it should be for every architect, kind of get rid of yourself. It doesn't make having the role. It's a bad role. It shows that something is a bit wrong. Yeah, there should be some coordination, but you're doing some kind of unnecessary work in a lot of ways. And like why we thought that this role is needed and why we wanted to focus on it was mainly, first of all, multi-DC. So we wanted to be available in multiple locations, serve the US customers close to them, serve the European customers, especially as we knew that GDPR is coming close to Europe. Together with that come a lot of other things like Dockerization, microservices, how do we scale the teams now that we have that much kind of potential, money, so how to scale fast. And third of all, and yeah, that I feel kind of we clearly did not do as well as we could have on moving to this kind of asynchronous patterns that the previous talker was just mentioning about. I know how hard it is, so kudos for even kind of going there and going out with these kind of brave things. It's harder than it looks. Been there, tried that. And why I talk about Anarchy is, no, it's not that. It's just Karina went on vacation and this is the first 2 hours in the office. But what I mean by Anarchy, it's actually the decentralization. So Anarchy itself never means that it's chaos. It's everybody's doing whatever they want. It's usually like a sufficiently small group doing things so that it actually works. Like somebody needs to be the doctor, somebody needs to do this, somebody needs to do that. So it's about finding that group that is sufficiently small but still manages to work. And if you don't know what Pipedrive is, because you probably don't, most of you are not, like we don't have that many people here in Czech Republic or Czechia. Is it now Czechia? Czech Republic. Nice. I've seen the other word used somewhere. It's sales management for fast-growing businesses. We have these numbers I need to always check. We have over 80K of paying customers from 170 countries, 484 people working from 42 different nationalities. Apparently this is going to be 50 soon. And kind of how it came to be is that two of the founders were actually sales guys themselves. They were actually doing sales training and they felt the pain because most of the time when you were doing things for the sales, you ended up doing the sale and then later on filling in the documentation, so the actual sales software. I actually do most, like, I was doing a mission and I did the same with Jira. So it's kind of, if it's counterintuitive, it doesn't work for you, don't use it. And yeah, and the main focus, this is the original version, looks really bad, you can tell me to the face, because it actually does. This is a newer one, still can be improved, always. But the focus has been on salespeople, and mostly for them to actually do it at the time when they do the sale. So it's not that I fill it in afterwards when everything is already done, but I do it right now to keep my own focus on something that I need to do, like some activity. I need to call some customer, do some kind of next steps. And yeah, when I joined was around, I think, 2014. So the graph actually, it has nothing to do with me, completely no. I just have a good nose for when the money comes into the company. And I joined around that time. So we had a couple of issues, but actually scaling the infrastructure was not the big one. We had some software that was written in-house that clearly did not perform, that was like affected by the network effects and stuff like that. But in general, either accidentally or by, yeah, I think it's more like accidentally, we had made the right design decisions that are questionable for a lot of people. Every customer has their own MySQL database. Like, what is there to scale? You just need more servers, that's it. And as for the infrastructure, we went with AWS. I think it's because of the owner's previous experience with them, so they had startup ready before. But anyway, AWS, we've tried it, we use it in some pieces, but it is a bit expensive compared to running everything in Rackspace. It is actually quite a bit more expensive. So, considering the fact that we need to run a lot of MySQL instances, the cost of servers actually is important to us. And mostly everything runs on virtual hosts. Operations team takes care of all of the networking, virtual machines, setting up the Docker swarm, also things like, I guess, like databases, key value stores, things like that, setting them up, these are not Dockerized. And we, in the near future at least, don't plan to do it. But yeah, the rest is Docker containers. And since the beginning, how it has worked is continuous value delivery. That means like we deliver a lot, we test a lot, we break things, we move fast. And it's fine when you do it in a small team, but if the team grows, then the role of the engineering in the fast-growing businesses don't be a bottleneck, so don't kind of get stuck somewhere. Just do the product, focus on the product. That's what brings in the money, and that's what drives you forward. And why microservices? Because we felt, yeah, it's like my code is being deployed, merge conflicts. You don't even need to be a big company, because I'm not even referring to Skype right now. The merge conflicts, the worst ones I've seen was in the other one, the engineering one, CAD files. It was crazy. Sometimes you did something and then you solved the merge conflicts for 2 days, 3 days. And what we had 4 years ago was basically this. So central PHP core app, then a lot of these small databases, RabbitMQ, then microservices, whatever, call them how you wish, the queue consumers that do something, maybe 10, 20 of them, and no service discovery, everything handled by chef, configuration files. Front end was Backbone. Yeah, is the logo Backbone? Am I correct? We don't have it anymore, that's why I'm asking. And the approach we took, it's legacy in a box. It's apparently a term in, what's the SolidWorks, the consulting thing? They actually invented the term legacy in a box. So if you just like shove it somewhere away, you use the existing API, then it's, it has a nice term. You can refer to it as a legacy in a box. So the API actually is good. We found out that. We are using it still to this day without any major changes. So we've been really lucky in regards of that. The original API design really paid off. And how we thought moving to microservices end is, yeah, there's actually, this is an elephant. I don't know if you've spotted it. But it actually ended up more like this. So there's clearly the elephant in the room. This is the one thing that we did not solve, and it didn't work exactly how we expected. But that's a lesson learned as well. But mostly why we did it is to scale the organization, scale the people, scale how the development works. And the way to do that, or why we thought it works better, is empowering the people, giving them more responsibility, more control, more ownership. As with any monolithic code base, the thing that you quite often see is people getting stuck on things they want to do. They get into discussions, which way is better. They lose all of the focus to the product. And to be honest, like from coming just recently from a mission of developing product, I can tell you that the thing that we wanted to accomplish, we clearly have. Because most of the mission time, all of the developers were providing actively feedback to the UX girl and also the product. And I'd say maybe like 50% of them actually got implemented. So that part that we wanted to address and achieve, we clearly have. And yeah, and another example of the kind of ownership is the on-call duty. So you build it, you run it. You don't want to build it in a way that you get woken up in the middle of night. So it's just a way how to kind of make sure that things work. And why I do think it looks like a corporate slide, but why I do think that microservices are important is mostly because you do small changes, and small changes are easier to do for the human brain. You don't get tired, you don't lose focus, they are easier to control. And the only way how to do that is really If you have small teams that know what they are doing, you have constant deployments to live. If you lose one or the other, it's not working the way, like it will always affect the speed by which you deliver features. So I took this graph today. It's around 100 deployments per day, apparently. The deployment times are different because it really depends on how many tests people are running on it. And you can clearly spot the ones that are old core services or services that have grown out of hand. Those are the ones that take 70 minutes, 30 minutes. But I think around 10 minutes is a good mark. Like if you can deploy in 10 minutes, it's not the fastest, but it's okay. But yeah, these are all of the different services, and the latest statistics is we have 800 repositories, 450 deployable components, and in the month of January, we did 2,000 deployment requests. So this is basically when you mark in GitHub, I want to deploy now, and it goes to some stage, maybe it fails, maybe it succeeds. It can be unit tests, it can be functional tests. Sadly, it's functional tests mostly, because people don't know how to mock things out. But yeah, out of those, a good portion still survive and end up in live deployments. And during January, 186 distinct components have been deployed. So there's a lot of things moving constantly. And in regards of microservices, we clearly love it. It's an experiment in progress. We got into it at a bit of a dangerous time because apparently besides us, nobody else had any clue what's going on and what to do. And yeah, to be honest, it's a really fine line between decentralization and chaos, because we also witnessed in some cases where, especially while we were running really small teams, like Scrum team size, 7-8 people. And what we witnessed is with such small teams, you often end up with software that has the exact shape of those 2 backend developers that were involved in the project. So you really need to kind of balance things out. Some things work nicely, some things don't. But how do you keep it in check, and how much should you even? So probably not that. Otherwise, I would be working in a different company. It's some European regulation. This one, yeah, is not about the shapes of the bananas, but eggs. But you do need some control. Key thing to kind of do is trust the people, and I think we didn't do it enough in the beginning. There's constantly the question, like when we introduce a new API, like every single developer can add a route to the live app, so they can create an API. Somebody is going to create something that conflicts with others, they are going to take everything down, it's not going to work, it's going to be chaos. Never happened. Same for pretty much everything. Like we were so scared about giving the developers control because we come from different backgrounds. We, like, at least I do, from a relatively big corporation, I'd say. And you learn to solve things quite often in the way of control. But sometimes it makes sense to also relax, let it go, and control as little as possible. So what we do control by now is languages. We do have a really strict list of languages. And the asterisk, it means that we accidentally thought TypeScript is the same as JavaScript. It actually is not. So we've made our mistakes. I do love TypeScript by now, but it kind of sneaked in without anybody actually approving it ever. CI/CD tooling and hosting, like, yeah, with some exceptions. If it really makes sense, putting stuff, again, like every single thing here is an asterisk. Now thinking about it. Like if it makes sense putting things in AWS Lambda just because it scales well and you can run it on whatever, like some kind of environment that is not supported by us, yeah, do it. doesn't make sense investing in and making it possible to use it generally. Storage options, they are limited. Again, similar thing. We support MySQL, we support CouchDB, and that's pretty much it. But if you have a really good reason of doing something, it needs to really like fill a purpose. If you can't do it in any other way, you can do it, but it's like so convenient to use the existing storage options. Most of the time you just don't want to. Service discovery. This is again a thing where we just build something on top of it. Just because if it's a solid API, we know we want service discovery to work like that, then it doesn't matter what it is. We are using console. We might use HT when we move to Kubernetes to do things like that. But the signatures and all of the API and the contracts, they are the same. We don't need to think about it when we move from one provider to another one. And yeah, GDPR, multi-DC, can't really do anything about that. It's a different scope, like you can't beat legal. And on-call duty tooling, escalations, all of these processes we keep the same. It's just so that when something breaks, there's a clear kind of line of command, ways how to handle these things, and we know whom to turn to. Operating system, again with an asterisk. Mostly because we are running stuff in Docker containers and it's easy to like run stuff that uses the same kernel. That's it. And we really don't want anybody to compromise and do manual testing. It's for main purposes, if you do manual testing, you are not fast enough. It's okay to do it if you wish, but you need to be able to deploy, being sure that things don't break when you do it. And yeah, it's been quite a ride. And what I've learned, mostly myself, is that greenfield projects are scary. Copy if you can. I did the same similar talk like 2 years ago in Estonia, and everybody was asking me like, would you build like a startup with microservices? And my answer was clearly no. No goddamn way. Never. I would clearly invest into doing things that matter more, product, like delivery, testing things out, and think about it later. At this moment, I think the tooling is good enough that I could say, yeah, you should probably give it a shot already. But 1 year ago, it was still kind of iffy. Trust the people. We were so scared of the people, nothing bad happened. And yeah, Scrum team size. This is one of the things that was kind of counterintuitive. You think that if you have a small team, then everybody exchanges the information, everything works nicely. Funnily, having larger teams, like maybe 15, 20 people, work better because people need to be replaceable, especially here where you have so many trams. They are going fast. I think a good team size is somewhere between maybe like 50, 20 people, but constantly rotating and having people work on different things. Otherwise, they get stuck, they get bored, they leave, they have other complaints, whatever happens. And, you know, architecture role, one of the main things is like, why the hell don't you use this or that one, this like available software? We've done it. But we've done it in a way that we usually add something on top of it, like a really thin abstraction layer that solidifies or contract or expectation towards that software. And it has worked. Quite often the software does not really do exactly what it tells it does. And it's easier to then hide it away with other tools or kind of duct tape and glue behind the scenes. But you are describing what you want the software to do. You start implementing it, and if it doesn't do what you want it to do, then you can fill those gaps easily. And yeah, the elephant does not go away by itself. So this year we are investing quite a lot more resources into getting rid of the elephant. And thank you. Is that you? And MVP, talk with him.
So let's ask questions from the crowd again. Who wants to ask first?
So you mentioned you got about 450 microservices deployed.
Deployable components. These are not
yeah.
necessarily microservices, but they are something that can be separately deployed, I think.
So I reckon still it's a complex system, decentralized system. So when something breaks, how do you identify what broke, what part of the system broke, and whom you shall call?
Yeah. So we don't have many kind of synchronous stacks on top of each other. As I mentioned, the elephant is there, but in a lot of cases, these microservices that we are talking about, all of these deployable components, they are closely related to each other. So they are maybe just simple queue consumers that take something for the elasticity. So you can receive some package coming from the internet fast, and then it goes to the API. So quite often it's maybe 10, 12, 14 components together, and they have their own SLAs that should work end to end. They do have their own metrics, and it's not that hard as it sounds. The debugging was clearly more difficult actually before moving to the microservices. What is hard though is queues always. Like if you have shared brokers and they get hit, it's really hard to pinpoint who is hitting it and why. At least with RabbitMQ. Kafka, we don't have that much experience yet, we are implementing, but yeah, it's not easy in some cases. But generally, these microservices live their life of their own. The last project I did, I started with 2 containers or 4, ended up with 16 in the dev environment.
So your answer is like, if you can isolate the issue on a business level, it's probably easier for you to tackle it rather than if you had infrastructural issue.
Yeah,
isolate
it from the business level and just go. Like everything else that you can duplicate. So even the smallest services have their own CouchDB instances, MySQL instances. Like in dev, you are running your own Prometheus and Grafana just because you don't want to mingle with others or like make it messy. In live, obviously, it's about reusing the resources, and it's a bit more different. But we don't have that many issues of allocating the issues.
Okay, thanks. Can I steal time for second question? All right, cool. So deployments. So you said you continually keep deploying stuff like 100 deployments a day. Mm-hmm. How do you ensure that when you deploy X number of services or components that they do not break the system overall? I guess there must be like fairly solid functional test suite you run. And if so, isn't time the concern? Like how long does it take to run all the tests?
We don't run end-to-end tests on the whole system, just the component that gets deployed. The ones that have heavy testing on it, it's clearly the kind of core part of the web app and the core part of PHP that are the legacy of the old or new, call it how you want. Those have long-running tests and they do extensive testing, but everything else we expect the APIs to be there. Some teams do use contract-based testing, but not that much. We haven't really figured it out yet and got it working properly, but we usually mock out every other component just by the knowledge of what we have about that component right now, and we fix the door system, like that one microservice that might contain of, let's say, even 12 containers, works perfectly if the other system responds this or that way. So it's like one part of the contract-based testing. We don't run the other part.
So you reckon you do not have heavy dependencies in between the services?
Yeah, we just mock it because, like, ideally, the correct answer to do it ideally, I think, would be to do proper contract-based testing, record, replay, and test it on both ends. But we haven't managed to get it working.
Okay, thank you.
Hello.
Hello.
I want to ask if you have a separate team caring about infrastructure or you have infrastructure people within microservice delivery team?
We actually don't have infrastructure people in the teams. We have a separate team, and the key focus is the networking, the storage, and this kind of general aspects that developers usually don't know how to do. Databases obviously is one. And it has been working nicely. The second team that we have as a kind of common team is it was originally called QA team, then QE team. I think the correct word for it is right now the build team, because we do have a lot of things that we are building. We couldn't find anything at that time when we were building it that worked out of the box, so a lot of it is homemade. I think right now probably we would not build everything in-house, but at that time it made sense. And this is the other team that really kind of covers all of the other team's needs. So we don't do in that sense DevOps. We have Ops, we have Dev. When we were doing DevOps, like let the developers change the chef code, then the fact was that nobody dared to do it.
Thank you.
Hi, can you hear me? Thank you for the presentation. I was wondering, like, you have customers all around the world. So how do you synchronize the data between like various data centers around the world, or do you have like? So we have like one database per customer in their location. Yeah, the customer's database is in their location. If they are going in, let's say they are right now traveling, they are in US, then they go to a US data center, and the proxy in front of it routes them to the European data center. Okay, and there's no problem with latency or? Well, obviously there is, but the customer must choose where they are. Okay, fair enough. Yeah. we don't have like, yeah, we do, but I mean like we generally serve customers that are relatively small, as I mentioned in the product part, and because of that we get off probably easier than we would when we would serve 500, 1,000 like people customers. Okay, thank you very much.
Hi. Hi. A bit of a niche question maybe, but one I'm very interested in. So how do you make sure your microservices are always kept up to date when it comes to code base? As in you have dependencies, you know, and you want to keep them updated, and when you come up with a new way of doing things, you want also all the microservices to start doing it like this, and so on.
You know, that's one of the things in which I'd say still up to this day the tooling sucks. So there's different ways how different teams are doing it. Some just keep like a central registry where everything is kept. The other ones just keep everything in a library, deploy, and make sure that that library version is used. Ideally, I would think that we should build an artifact repository, so when anything changes, everything gets triggered magically, tested and rebuilt, but we are far from that, and I think the general SaaS offering right now out there is quite far from that as well.
Hi guys, I'm Tomáš, and I'm the migration squad lead in Kiwi, and I'm responsible for the migrating of Kiwi services and infrastructure from our current state to GCP. And Yuri?
Yeah, it works. So my name is Yuri. I would not pronounce my surname because it's like quite tricky, and I had like a nice story when American cops tried to pronounce it, and who did it like best will won, but not about this. So I am a DevOps engineer in Kiwi, or infrastructure engineer, or platform, whatever. So I work on different things, but related to the platform and infrastructure. All right, so you should click this. So what we will speak today about, we will shortly show you the current state of our infrastructure and things, how they are going on, about the processes, of course, about challenges that we are facing with, and migration, of course, how we do this, why we do this, and how we handle the different problems. So the current state, we have hundreds of services, like different projects, products, and so on. And we are making like hundreds of deployments every day. We have tens of teams like which are handling all of these services, developing them, like growing, maintaining, and so on. We're growing really fast. So all the processes that were relevant like few years ago or even a year ago, some of them are not that good anymore because they simply doesn't fit our growth and company, and we cannot handle some problems which we could handle like when we were smaller. Every second matters. That means that every outage of the system, every problems that we are facing with, we are losing money, and we don't want to lose money, so everything should be stable, like working properly without any outages. So, and one more important thing to mention, we have centralized DevOps platform infrastructure like team. We do not have separate DevOps engineers in every team that could handle some infrastructure problems or CI/CD pipelines or help teams simply with different kind of problems. So all that kind of stuff is handled by developers in the team. So everything should be simple, quite easy to use, that developers can handle this on their own. And of course, we are trying to keep everybody happy inside the company and outside the company, our customers. So,
yeah, I will talk about current infrastructure. As you can see, we have AWS. We have some bare metal servers in Hetzner, Docker, and Rancher. The story behind it is like when Story started when Kiwi started a few years ago. We saw Docker and we liked Docker and everything was in Docker. Then as Kiwi grew, we needed to orchestrate all our services. Then we deployed Rancher and it was super easy. It was fancy UI. Developers can just click and hey, deploy my service. And we saw the logs there. We saw some metrics, something, and it just works. And one of the things, Rancher can manage multiple environments. We are managing the bare metal servers with Rancher. Also, we are managing the AWS services with Rancher. Basically, on AWS, we have majority of our services. On bare metal, we have now the core database, which is Cassandra cluster, and all the services based around this cluster, because we need to have those services as close as possible to the database. Yeah, I wanted to start new service as a developer, and what I need basically is just new DNS record pointing to some load balancer. I need SSL certificates in place for this service. I need AWS account and other things for starting the service. Then in current state, it's like, hey, I need to create the request for DevOps because it's centralized, and as we are growing, it's unmaintainable because we have hundreds of requests every week, and we have like just 10 or 15 DevOps engineers, and they just can't handle that scale for now.
yeah, and that's true. Like, say DevOps every time, like, please DevOps do this, please DevOps do this, create that. And it's like making us crazy, and we don't want to do this like manually because it's like in an appropriate way. So everything should be somehow automated, and even better if you will not do this at all.
Yeah, but we are DevOps. We have some things in Terraform, and all you guys do know Terraform, what it is. Who don't know Terraform? Wow. Okay, Terraform is a tool which can help you manage your infrastructure as a code. In Terraform, you can basically have AWS, you can have their Google Cloud, you can create your own modules, you can create your own, how how it's called, it's not module, it's the providers. Basically in Terraform you can use everything which have API. Then you can have as a code the cloud providers. You can have Cloudflare, you can have Datadog as a code. You don't need to click through Datadog, create new dashboards, create new alerts. You can have PagerDuty policies in as a code because it have the provider and basically everything with API.
Yeah, I mean, basically the reason for using like Terraform in all other like companies and so on is just keep your infrastructure as a code, because it's like easier to track changes and you are not running to find somebody who did like changes manually or something like this. You can just go through the code commits and you can see what changes were done and what were like their purpose. But like we are growing and we don't want to use like this tool only for infrastructure part. We can use this like basically for everything that we want to keep track on it. For example, like Cloudflare CDN. Do you know about this? What is it? Yes. So when you're creating some DNS records there, like proxies and all other stuff, you want to keep track on it, or creating some limits or firewall rules and so on. When you're working, when a lot of developers are working on this, or engineers, it's getting messy because nobody knows like, is it relevant or is it not? Like, who did those changes, who like reward them, and so on. So if you are keeping track on it in the code, it's like pretty easy to use, and you can just, if somebody needs some changes, you can just give them the link to the repository and say like, hey, create a merge request and I will approve it. That's way easier.
Yeah. And for starting new services and stuff, we are using Cookie Cutter. Who knows Cookie Cutters? Wow. Okay, Cookie Cutter is basically a tool which is helping us to build the configuration and is based on templates. It's basically Jinja templating for services. We are using it for starting the Python services, for starting Go services. We have there the manifest for Kubernetes, and it's just one command which prepare everything for you. We will talk about this later. We will show you how it works in our case with Kubernetes and Google Cloud. And yeah, it works. We have everything, and why we just don't hire a few more DevOps engineers and everything should be fine and shiny and it works. Then why are we migrating when we just can hire people and it will be fine? One of the things, the main one is Rancher is not scalable for us. It has some limits in amount of containers, amount of namespaces, and we can just easily add new 100 of namespaces for developers. Then we decided to find a new technology, and we saw Kubernetes, and we decided to go with Kubernetes because it has cool community around. It's well-known technology, and it's doing basically the same what Rancher did. This is connected with the scaling. With Rancher, we were unable to scale. We were unable to start the services as fast as possible. We were unable to basically add new services which are more complicated. Yeah, and that's it. Yeah, then there is also migrations coming, and for this we decided to go with Google Cloud. Why? Because we decided to go with Kubernetes, and back in the days AWS doesn't have any managed Kubernetes, and Google is basically inventor of Kubernetes, and they have the most experience with managing the Kubernetes clusters. And it's super easy to start with. They are managing whole control plane for you. Then you can just buy some nodes and say, hey, please Kubernetes run this application and it's fine, but that's not true. It's not that easy. And it's not that easy because you can just say, hey, take your container and run it in Kubernetes. There are differences, and we will talk about it also later.
Yeah, so we are migrating to the GCP, and should we use Terraform there? Like, the answer is, of course we should. Like, it's very simple, the tool stays the same. We're just choosing another provider, which is Google. Basically, all the knowledge about tooling, like the syntaxes and other things, that keeps the same. We're just simply using another definition of resources and work with completely another provider. So we are migrating to completely another platform, another orchestration tool, but the problem stays the same. Like each project should handle you should handle for the project DNS names. Like it should be not only one, but probably a lot of them. Like SSL certificates, secrets, different kinds of them, how you should handle it. You should think about this, because if the company is growing and the products are growing, it's getting really messy if you don't have any organized stuff there. Also, you should follow some best practices, of course, because we had already problems with it. I mean, when you're designing system or you're thinking about tools when you're in the current state, for example, like you have 10 services and that's it. So something will work for you perfectly on 10 services. But if you will grow to hundreds of services in 1 year, those things are not relevant anymore, and you will need to change everything. So now you're designing everything to keeping the growth in mind, like to make it easier in the future. Also, you have a lot of toil. It's like an abbreviation from SRE stuff. Maybe you know, maybe not. So basically, this is like all the tasks that are pretty annoying, but which you're facing every day. Like, please do that, please do this, and God knows what else. Like a lot of different things. Like now, we will try to share some best practices that we are trying to follow.
Yeah.
Yes, so that could be really obvious, but multiple project environments. Trying to keep always at least 2 environments, development and production. You should keep it easy and simple. Because as I mentioned before, we don't have separate engineers in the product teams, so we have everything centralized, and if it's deployed or rolled up, developers are taking care about this. So you should keep it as simple as possible that they can able to handle all the things on their own. So of course reduce your own pain, all the domains creation, certificates and other stuff. You want to keep everything standardized because if you will help some product team fix problems that are out of their domain. The next week you will help another team, in a month you will have another team, and you want to keep things in the same way. That you do not spend a lot of time investigating, reverse engineering what the hell is going on here, where you can find those things, where this is stored and so on. So you want to keep everything the same, that you can easily switch between different projects. Test before release. That's maybe, again, obvious in the application development. Of course, tests, not without it. But if you're working as a DevOps and writing Terraform configuration and so on, usually you don't test it at all. I mean, you're running it, it's working, and it's fine. But if you're going to spread all these configurations, nice. So, but not a big deal. Okay, so you want to keep it really working before rolling up to spreading these configurations to all the teams, like to the mass market usage, because it will reduce whole pain. I mean, questions from the developer side and different enhancements. So what we are doing, there are some people that are in the team that are responsible for developing different parts of the modules, the templates, and so on. And when they are done, other team members from platform team or DevOps engineers, they are trying to do all the steps, to use this modules on their own. If they're facing some problems, they are discussing it with the maintainer, and then you're enhancing that documentation, enhancing the modules on their modules, and maybe removing some unnecessary stuff. And when you're rolling out, releasing new tool to the teams, it's already pretty clear, or at least you have answers to a lot of questions that teams will not ask and bother you. And the important thing is that we are trying to use the benefits of GCP. That's organizing all the projects. AWS doesn't have this feature, so if you will go open the region, EC2 instances page, on the AWS, Frankfurt region, you will see all the projects, all the servers from different projects. On GCP, you can split them, separate completely, and organize pretty nice. So stop selling all your stuff here. It will be nicely organized, spread into different projects, and the resources will be not crossed.
Yeah, and I wanted to add one thing. It's maybe obvious, but we have the huge advantage of migrating to GCP. We have a green field. We have a space to prepare all those best practices, all those cookie cutters and templates, to give developers a really good experience with Google Cloud. Don't fail again, because as we were growing and there are not that good infrastructure, and now we have the opportunity to make it much better than we have now.
Yeah, that's true. And now when migration to Google was announced, everybody in the team, different product team, they want to migrate as fast as possible, or at least that is one of the goals for the future months. So you want to keep it really simple. So the migration of the services, we did it in 3 steps, or basically 4. I will show you how it's done. So the first step, we are talking now about infrastructure, resources, and all the things, how to organize it and keep it nice and clean. So the developer, of course you want to spread the load from yourself, so you prepared everything and give it to developers, and they are doing on your own. You're just approving the merge request. So they are creating a new repo on the GitLab. The next step, they are just copying new project ID and creating a merge request in the GCP project repo. The code snippet looks like this. That's the Terraform module that we wrote. And basically, he's just setting here the project ID and subdomain that he wants to use. Additional information here, but it's nothing, not a big deal to change. And then the magic happens. When the merge request is approved, the Terraform, the CI is triggered, and the Terraform module starts doing all the stuff on the background. So as you can see, we have one tool, but which can cooperate with different providers like GCP, Amazon. Let's encrypt Vault. Doesn't know Vault? Okay, Vault, this is another tool from HashiCorp Corporation. HashiCorp built Terraform. Also, they built Vault. And this is basically the secret storage, which is pretty awesome. I highly recommend you to check it out, but not about this right now. And also it pushes the notification to the Slack channel, which looks like this. Oh, too early. Okay. So we will go through the resources that Terraform is creating. It creates for us the new GCP project for our service. We're organizing things, so it creates in the subfolder. So if you open the list of projects, it will be nicely organized. Terraform state bucket. Basically, it's like S3 bucket where we but on Google, where we will store the Terraform state for it. It's a DNS hosted zone on row 53 for the particular subdomain that you set in the module. It will issue the SSL certificate for that subdomain that you set, that you can use it in your load balancer for HTTPS. It creates you the project pass policy tokens on Vault to store your secrets, all the database passwords and other stuff. And it will automatically pass all the CI/CD variables into your newly created project to make your CI working. This is the Slack notification, how it looks like. So basically, like the information that you set in the module, and here you have the pre-generated like fancy command. Everything you should do, click the button. You're just copying, pressing enter, and everything is created for you. What's created? It's automatically push all the infrastructure code to your repo, newly created repo. It automatically triggers the CI pipeline for you. The CI will build all these resources that are described in these files. That will be the new Kubernetes cluster. That will be like specified node pool, load balancers, users, and like namespaces in Kubernetes and so on. And that's basically it. Demo, demo will be in screenshots because it takes time, so to speed up it, we will do like this. Me. Thank you. So you're creating the new project repo. It looks like this. Copying this ID, making a merge request, setting it ID here. Some information, let's say for owners, about owners, the next slide. Then somebody approves your change. You can see that Terraform will add like 39 resources, create for you. Now it's more. Then you get the notification in Slack, and this is how cookie cutter works. You're just copying this command and answering simple like questions. You're doing this only once, so for developers that's super easy. You cannot screw it up, like you're just answering questions. Or even some of them you don't need to answer at all because they are pre-filled based on the information that you pass to it. You just basically checking out it should be like a sandbox or production project, and do you need to use a shared VPC or not? And voila. It pushes this code, this changes automatically to your repo, and you should wait when your cluster will be spinning up. So that's it.
Yeah. And this whole process take like, for developers, like 1 minute, and the creation of the project and all the resources is something around 10 minutes, and you can start pushing your code to a repository, deploy the application, and develop. It's super easy and it's fast. And what's our next steps? Of course, collect feedback. This is our new initiative, and we gave these cookie cutters and project creators to our developers, and now we are collecting the feedback, what's working, what's not working, what they are missing, and why. And we are adding those resources and enhancements. Add more resources. As you saw, it's just only for Google projects and owners and managing users, and Google Cloud, Google Kubernetes engine. There are no resources like memory store for this. There is no database. There is not Google Cloud Storage and other things. There is. Yeah, and now we are working on cookie cutter for Kubernetes service. It's already in alpha in our company, and it's again, just cookie cutter is just one command which asks you what you want to deploy, and it creates all the Kubernetes deployments for you, and it's you are supposed to just change the things based on your application. It creates for you the service definition, it creates the deployment definition, even the PDBs, pod disruption budgets, it creates the auto-scaling for you, and your work is just to change the values you want to scale on, or amount of nodes, or health endpoints and stuff, because we are also teaching our developers how to operate Kubernetes. Then they know what they are changing and why. And our next step is open source those cookie cutters and Terraform modules, because we believe it should be useful for other companies and save them some pain. And what's next? Yes, and as we are migrating, we are facing the issues, as everybody does. Yuri, I think you can say the first one.
Okay, so basically this is the problem that was connected to testing before 1.1. Works?
No. No.
Ta-da.
Just a second.
We hear you. Come to me again. So, knockback, that connects to the test before releases. So basically, we had the first version of our templates and Kubernetes and Terraform module ready. We rolled up it for the first application that was like deployed and so on. Suddenly it works perfectly. So just to be clear, we have a new project repository where we store all the infrastructure resources and Kubernetes manifests. Application repositories are just triggering a pipeline from that infrastructure repo. That means it's just application pipeline, just pass some variables like Docker image, version, other things, environment variables to that pipeline. Okay, I hope it's clear, to the infrastructure repo pipeline, and it executes the deployment to the Kubernetes. What we once did, like there was some hotfix from one of our engineers, and he just completely forgot about it, and nobody knew about it. Also, he was like testing some new features there, and they just stayed living there forever, and nobody knew about them. So we were expecting that this code works how we expected, how it should be designed. But when we triggered the pipeline directly from the infrastructure repo, it just screwed up, because there was like there was an old hard-coded old value of Docker image months ago, and suddenly we deployed just the version that's like not like pretty old one, and it's just it just failed. So when we started debugging it, it like turned out that you should not run this pipeline from this repo, so not because it just doesn't work. Actually, it was like our gap, but we are learning on this. I hope all my story was clear. I hope so. But okay, so the conclusion of this is like to learn on your own problems and like make some conclusion, just do not step on the same issues.
Yeah. And another one is why it's working on AWS and why it's not working on GKE. It's just container, it needs to work, it's working on my machine, it's working everywhere, right? No, that's not true. We just migrated some service to GKE and we thought, okay, it will be fine, just copy the container, run the container, put there some probes, put there some limits and it will work. No. There are differences, and as you can see in next points, Kubernetes doesn't forgive you lack of knowledge. You really need to know what are you doing. You need to know which probe is doing. When you have like liveness and readiness probe, you need to know what times you need to set for what, because it can easily just disconnect all your application containers from load balancer and you are basically down, you have an outage. Another thing is like, okay, you have huge limits, you have huge amount of containers, but your application is still not working. Why? And we were investigating this like week or 2 weeks, and we discovered the kube DNS is just slow when you are hitting it with hundreds of thousands requests per second, because you can't manually scale kube DNS. It's scaling automatically on some formula based on number of containers, number of nodes, and does other magic things. And you can't just easily say, hey, scale up the DNS because I have heavy load. No, it doesn't work, and we need to figure it out how to handle this. It looks like for now we will start some DNS cache containers and other things. Current GK version doesn't support grace period for downscale pods. It's super cool when you are under load and your application is scaling up and you survive the load, everything's fine and shiny. Now you downscale to, let's say, 20 containers from 50, everything's fine. Okay, we survived, we saved some money and everything, and now we need to downscale the nodes itself because we downscale just containers. And Kubernetes is supposed to do, but it doesn't. You need to do two things. One is the annotation, which is called save to evict, because when you are mounting some volumes, the Kubernetes, it's not just unmounting the volume because he thinks it's still in use and other things. There is some magic behind it, but this annotation should help, but it's not 100%. And for this, we are using some third-party service, which is just checking amount of running containers, amount of running pods, used and unused resources, and based on this, it's just manually downscaling the nodes. I don't know if it's some trick of Google to how to get the money from Kubernetes or whatever. And another thing is databases and serverless. Databases in Google Cloud, we have few options, and we are using heavily the PostgreSQL. And PostgreSQL in Google Cloud is in general availability from last year, I think from June, July, something like that. And it's not that good as on AWS. You can't just use something like point-in-time recovery because you have just one backup per day. You need to write some your custom scripts to do backups, let's say every hour, to have at least something. You can't change parameters of the database as you can in AWS. For example, a read replica in Google is basically unusable because there is like 30-second limits for the query, and when you have like a huge query, you want to just read something for, let's say, analytics and stuff, you can't because Google is killing your query after 30 seconds. Then you need to run all the queries on the master. It's not good. And another thing what's happening with Cloud SQL is to have maintenance window. And even you have available database and everything's shiny and you think it will work forever, that's not true. Google is restarting the database in maintenance mode every, let's say, 3 months, and the downtime is much bigger than on AWS. On AWS, it's like few minutes, like minute or two. On Google, it's like 5 minutes plus, depends on the size of database. And it's not good, and it's happening every 3 weeks, and I experience like one maintenance on Monday, a second on Tuesday. It's not good for customers and stuff. And serverless on Google Cloud, it's usable for things like when you are triggering the Lambda, the function from PubSub, when you are triggering the Lambda from Google Cloud Storage. But you can't use any other triggers because you can use HTTP trigger, but it's not that good as on AWS because you basically don't have the API gateway. You need to specify allowed methods and other things in your code. Then only 2 use cases for Lambda are those, and I think a week or 2 ago they released the scheduler for Lambdas, but it's again based on PubSub. That's funny. And what else?
Yeah, I would like to add like one. Okay.
And last thing is have a plan. When you have like a huge company like Kiwi is hundreds of services, you can just go YOLO to cloud and say, hey, just migrate everything, and say to all teams like, hey, we want to migrate, and we want to migrate in 1 or 2 quarters. It's unreal. You need to have a plan. You need to have the best practices in place, and then you can start migrating, learn the new things.
Yeah, the microphones doesn't want to make a friendship with me. So I would like to add that serverless on Google is like pretty silly. Like if you will compare it to Amazon Lambda. For example, you also cannot put the cloud function behind the VPC to have a single endpoint which you can whitelist in your security groups. On Lambda you can do this. So basically you're putting the function behind the VPC, and you can use NAT gateway IP to whitelist in your firewall rules. That's one thing. Another
And I have a secret for you. It's on a roadmap and it will be in beta soon.
Yeah. Use it. Another thing, it's about like Tomasz said it, but I will add something. It's about grace period downscale for pods. As we said previously, Rancher had some limitation in scaling. It's not that flexible, so we're trying to use the benefits of Kubernetes, like to scale pod horizontally depending on the load. And there is a feature there called horizontal pod autoscaler based on the CPU load. And it's quite good. It works pretty nice. So it scales pretty fast, and also it scales in pretty fast as well. So when you have this like average load jumping near your threshold, it's just scaling up and down all the time. And it could be like really bad for your application. And in the Kubernetes 1.12, I think, there is a support for the grace downscale period. So we can set like 5 minutes only. So you will scale one pod, then wait 5 minutes, then another pod. So you will be safe between always jumping between this like threshold. But unfortunately on JKE, this version is not supported yet, and you can make some changes to make it work on previous versions, but you need to make changes in the Kubernetes master. But on GKE you cannot do this because master is managed by Google in the background.
Yeah, and another thing, it's for developers. Developers really need to understand their applications. Because, okay, we can give them the manifest, we can give them the limits, but now it's like on the Rancher, it's unlimited. Developers have unlimited resources, developers don't need to take care. And in Kubernetes, they need to set the limits because you have multiple containers on one server, basically on one node. It was something what we didn't have on Rancher. Basically, we had one container, one server, and now it's changing. And I wanted to add one thing, and I forgot it. Yeah, doesn't matter. Yes. Let's do some promo. We are on 15 to 17 March. We are organizing Cloud Weekend in Bratislava. It's Kubernetes based all around Google Cloud. We will show you how to operate Kubernetes, how Terraform works. We have there even session about networking in Google Cloud and other things. Then if you are interested in Google Cloud, just sign in. There is just some simple task you need to do, and that's it. Yes. And this is the end. Any questions?
We can give one more.
Yeah.
I think this
Go on.
isn't working as well. It just needed a reboot.
Here, come on.
So, who wants to ask
I'll
the
give you
first
then.
question? Kristo.
My question is, there were so many things that you mentioned, like just the previous slide. And my main question is, how many of these things, like these details about how it behaves, it scales up super fast and super down, so you need to kind of think of the grace periods and things like that. How much of it is for the DevOps and how much do the actual developers need to know? Like me as a developer, do I even need to know about it when I write my containers or not?
Yes, but it depends on the application side. As we said before, it was everything running in Rancher. It doesn't have this like jumps so frequently. So basically, all this scaling, like if you had like a real load or some problems, that was done. Don't blame me, like manually. Okay. Working. Okay. But when we have some applications which are heavily heavy on the network. I mean, they're processing a lot of requests per second, and that's about like developers how it works like inside. But it turned out when we're jumping so fast, like from let's say like 20 containers and then back to 15, and then again, like their application is misbehaving. So that was one of the problems, and the solution for this, one of the solutions was like to set a grace period. I mean, if you're scaling up, it's fine, but if you're like going down really fast, their application was misbehaving. So we decided like to scale it down like one by one, but in the fancy way. But it was not in the box yet. So.
Yeah, and another thing is when your application is starting really slow, like my application is Java monolithic thing and I'm running in Kubernetes, and I want to scale, okay, Kubernetes is running new containers for you, but when the application is starting like a minute or 5 or whatever, you just miss the peak. You're down, you're overloaded, and the application dies, you have outage. And we are trying to ensure to say our developers, we need your application start and die as fast as possible, basically. With this, we can work, Kubernetes can work. But when your application is starting slow, dying slow, it's a problem.
Hello, thank you for presentation. I have a question about Terraform. Have you ever accidentally or mistakenly destroyed part of your infrastructure in a fully automated way? Yes. No. And if not, then what kind of safety belts you have, if you have ones? Because as far as I remember, Terraform can successfully destroy everything which is not in manifest or something like that.
One of the things is we have the creation and in the CI pipeline. And only CI pipeline can do the change, and before every deploy, we have the Terraform plan, and when developers doing the new pull request, then DevOps guy is looking at it, he check the Terraform plan, he see the changed resources after merge, he just run Terraform apply, and we really know what's going on.
So it's up on human to review the plan?
Yeah, it's like plan A, but always is plan B, because who is not familiar with Terraform, he stores all the current state of your infrastructure in some called Terraform state. So that's basically JSON file where everything is described about your infrastructure. So if you will delete this file, basically, if you will, and then you will run Terraform apply, it will just, you will just lost everything. So to have a backup plan, one of these, for example, we are using S3 buckets, and S3 buckets support versioning. So if some version will be like screwed up, we can use the previous one, which was like good one. So that's how we are keeping this in one place.
Yeah, and
works, of course, only for stateless infrastructure, which you basically can reprovision like web services, right? Nothing like MongoDB or
databases are managed by database guys, and I'm not sure they also use.
Basically, they
also use Terraform for this, I think, but I'm not sure how they are handling like the permissions, like of destroying something and like that.
Yeah, as you mentioned, for MongoDB, we are not using MongoDB, and yeah, it's for the resources. It's not about applications, the Terraform. Because the database is created via Terraform, all the users and everything, but the data are not created by the Terraform.
Yeah, but if I mean, it can be deleted by Terraform very successfully.
This is why you have backups. And everything's in CI, and when someone really wants to destroy anything and remove the project or cluster or anything, we just run Terraform apply, we run the CI which deploy all the application, and it's a matter of minutes.
You had backups before moving to Google Cloud.
Yeah. By the way, we didn't move the databases to Google Cloud. We are still, with databases, we are still in AWS. We have a tunnel between Google Cloud and AWS. And the Kubernetes clusters are in Frankfurt, and the databases are also in Frankfurt. And the communication between Google and AWS is almost the same, like in the same network. It's pretty fast. It's a matter of, I think, 3 or 5 milliseconds. Then it's like that. This is why we didn't move to the database. We are still in AWS. And for example, the Scylla, the main database we have now on Hetzner, it's a huge Cassandra cluster and some services around. And we have OVH bare metal now instead of Hetzner because of the reliability and network things. And we have again second tunnel between OVH and GCP.
Yeah, last question. I think you asked first, sorry, Tim.
Hello. Since you migrated to Kubernetes, have you considered Helm charts for deployment instead of Terraform, or?
Yes, but the Terraform is for creating the manifest itself. The Helm, it's just another templating, another layer. But for now, I think we are thinking about Casonet. You know it? It's another templating thing which is supposed to be better than Helm, because Helm can be really messy and have there all the if something, then something, and other things. We experienced this with Ansible, and it can be really messy. With Terraform, we are keeping it as simple as possible and readable on first sight.
Thank you.